Hello everyone, and welcome to my new channel, Remotely Physics, a channel where I'm going to be covering topics of physics that I find particularly interesting. Today we're going to be talking about the difference between microwave popcorn and gas stove popcorn, and what's happening as it's cooking. But in order to understand that, we have to understand that there are three main components to our kernel. We have here our water droplets, which is just trapped moisture within the shell. We have our starch, which makes up the body of the inside of the kernel, and then we have our hull, which is just the shell. And as it's cooking, the water turns into vapor and pressure builds up, and it needs somewhere to go, so the popcorn kernels will crack in order for that to escape. And at the same time, the starch is cooking. So when the water finds its way out, the starch gets to take its shape and giving us the crunchy snack that we know and love. But what's happening differently is the way that it cooks. The difference is that the microwave is fitted with a cavity magnetron whose responsibility is to send electrons that manipulate the water molecules within the kernel. And so you can see that the microwaves are sent across the bay and they bounce back equally, and we have a rotating plate here that allows for even cooking of the manipulation of the water molecules within each kernel. And with our stovetop, we have here, it's just that it's pretty straightforward. Heat from the flames come up from the bottom, and our pot is our vessel for the kernels that we need in order for this transfer of thermal energy to take place. So with that being said, let's get right into it. We're just gonna put our popcorn into the microwave using our microwave button for functionality and convenience. So we're gonna let that go. You can't tell because you can't see the microwaves themselves, but over here is going to be where our cavity magnetron is, and although we can't see it, those waves are being shot up and down and up and down until it hits a certain point, and it's going to come right back the same way it came. So while that's happening, we're going to start with this. Probably should have had that burning. Put a little bit of oil. You can hear our microwave popcorn starting to pop. So what's happening in there is the water molecules within the kernel are being manipulated by the electrons that are being sent by the magnetron, and the kernel can't take it anymore. The water pressure is built up, and it finally escaped, and the starch that's cooking also simultaneously, it's taking its shape. And that's why similarly the bag will begin to inflate because it's taking more space. It's looking like it's about done soon. We're gonna go ahead and add our kernels to the pot. So as you can see, flames come up from the bottom. The pot is the vessel. I imagine because the pot's cold, it's not instantaneous like the microwave, that it might take a little bit for that to start getting hot. Still popping over here. And another big difference between them is like microwave popcorn, it's gonna have its own butter and it's gonna have its own oil and it's gonna be flavored already. Whereas this kind of popcorn, I get to salt it, butter it, do whatever I'd like to it myself because I'm the one that's making it. I think that's a cool difference. Maybe you don't want so much butter, or maybe you like them dry, or you want to put super light salt or something. You get to control that. That has stopped. The popcorn stopped popping, which means we've gotten as much popcorn as we're gonna get out of that. Sometimes some of the kernels won't pop because the whole point of not the whole point, but that sounded nice. Some of the popcorn kernels will not pop because they already have holes in them. There's already a means for that water pressure, the water vapor, to escape. So it's never gonna crack. The starch will cook, but it'll never crack because it'll never pop because the water already has its way out. It doesn't have to burst through like how it does. And that's why we get the shape that we get, because it's so instantaneous, you know? It's not like a hole was made and steam can escape. Okay, so I do see a few kernels in there. It's actually a lot less than what I'm used to. Okay, our stove is starting to pop. There we go. That's getting pretty active in there. Probably do not want to open that now, not until it's done. Shake it up a little bit. Oh, there it goes. Boom. They like that. So enough heat is generating from the bottom of the surface so that the kernels are bursting in here. So what's happening is the kernel, the water is actually being heated up, evaporating, and it's bursting, and the starch is being cooked. All right, looks like it's starting to slow down. We're looking like it's almost done. It looks like all of them popped, which is not what I was expecting. Ooh, that. Poor timing. So put that aside. Need a little like spoon or something. So as you can see, it has substantially less color than our microwave popcorn because our microwave popcorn is pre-buttered and salted. There it goes. Let's see. Let's get something to scoop it out. So we're gonna bring our bowl over here. Oh, that looks very plain. Rightfully so. And let's go compare the two. Put some salt on that. While it's still hot so that it sticks. And there we have it. Here is our microwave popcorn, and here's our stovetop popcorn. Cooked differently, but same results. I would say that the stovetop popcorn had more success rate, less unpopped kernels, or no unpopped kernels. There are a few. But obviously you get to control that, or you get to have more control over how much, because when it's in a bag, you know, they're already in the bag. Obviously this is a healthier alternative because that just has so much butter and so much salt. You get to control how much. This is actually my first time popping stove popcorn. And apart from like it lacking butter, like I would still say that's just as enjoyable, you know. Me personally, I like to have my popcorn with like something spicy, you know, something to add a little kick to it. But yeah, so the difference is the microwave, it has the cavity magnetron that sends electrons into the bay of the microwave where it's going to manipulate any moisture that it finds. The molecules of the water, they're like forced to rotate, generating friction and causing pressure, and that's why eventually the shell will pop. Similarly, the stovetop heat comes up from the bottom, heating up, you know, the water molecules within the kernel, allowing it to pop and for the starch to cook, giving it its shape. Thank you everyone for watching. Hope to see you again sometime. Goodbye.